Okay, hey, welcome to this small demonstration of the proof of concept that I made for my client, and that proof of concept based on different technologies from different companies, but mostly from Microsoft. The idea and the goal of this proof of concept to show the reliability of Microsoft technologies to provide disaster recovery of the website, which actually runs within Microsoft Internet Information Server, like a web application running within Microsoft Internet Information Server, and that application actually works with the Microsoft SQL Server. Here on this scheme, I just basically showed not all but some of the objects that are made within Microsoft Azure within that project, and it's located in different regions. There are resources in 3 different regions in Microsoft Azure, and each region, actually not each, 2 of them has like this same technologies, this same objects, websites 1 and 2, Microsoft failover cluster, Node in this very scenario, this very case, and SQL database running in both of the regions. So these regions are like central, which is not so far from me, like located here in Chicago, and Azure East, which is I don't quite remember where, but like on the East Coast. So they are in different locations. And there is another resource which is called Cloud Witness resource, which is supposed to be located somewhere else, just to make sure that nodes of the cluster are not tend to, I don't know, to be on a split brain situation. So that's how it is. I will probably be back to this very picture later, just to show the details, but for now it's like a basic representation of the whole project. So what's the interface of the project? It's basically this I would say not so fancy, not so important application. And that application actually has like web interface, and it's written on .NET technology, Microsoft .NET, and it runs within Microsoft Internet Information System. But in this very scenario, it actually works within web application running in Microsoft Azure. But it doesn't matter. It's basically the same technology. And the data, like let me do something like enter something here. So right now we're on server 1. I will put something like this record is on server 1. I don't know if it's correct. It doesn't matter. It's actually just a record within database, and that database is located not so far from this very web server, and the name pretty visible here. So the name is like has that 1 in the name. Why it is important? Just like, I don't know, to make sure that you understand the concept. So for now, the application, let me be back on this very picture. We're working with this very application, and our DNS server actually returns that application as a correct answer, as a correct entry point for the request. And that application works with a web server which is called Bean1 SQL, and it's pretty visible here. So that's how it is. Let's pretend that our server is down. something is wrong with the server. I don't know what happened. Maybe there is some failure with the hardware, or like there is no connection to the whole data center or anything. It doesn't matter. So let's pretend something is wrong, and let me connect to the server. So I have the connection to, like, RDP connection to the SQL server, both of them, like 1 and 2, and it's kind of easy for me to start a manual failover to the other server. So for now, what I'm going to do, I'm going to start the failover procedure to the second server, and the second server, server number 2, will be the primary, and the server number 1 will be the, like, secondary, the failover server for the server number 2. It's kind of easy. There is no special operation, something like this. It's like just basically next. You just have to connect to the server, of course. What is happening right now? So when I press finish, the procedure of the failover will be started, and the whole source of the information, the source of the data will be changed. So let's do it. So I started it. It usually takes several seconds, not a long procedure. It's like yeah, it's already done. And after that, I will start the timer here. It just will help us to understand how it works and when everything will be accessible. So let me be back to my application. So what's happening right now? Probably nothing good, because yeah, I pressed refresh, and it's definitely not a good behavior, because it returns nothing, and it will show yeah, that's exactly what it will show in this very scenario, in this very situation. Let me show you these two pages. These two pages are actually the applications themselves. So there are actually, just let me be back on this very scheme. There are actually two websites, 1 and 2, and those are 1 and 2. Exactly exactly the same pages and websites. So if I refresh that one, I believe there will be, yeah, definitely there will be a error message. And if I refresh the second one, there will be like a correct page with the data which I just entered. And it's worth noticing that right now we are working with the database number 2. So this is the server number 2. And again, let me check it. Not ready yet, but for now I'm going to show you this part of the whole scheme. So for now, we had what we did. We switched like failed over to the server number 2. Everything, the data, like the initiative of the data, the source of the data has been switched to the server number 2. And for now, this very website actually which is working with the server number 2, actually works, and it's working and accessible. And that one actually returns the that ugly yellow error page or something. But there is another thing, another service which I use for this very installation, and that server actually it's external service, and it's located in it's named NS1. It's additional DNS server, and it's kind of smart DNS server. The idea behind that DNS server is that that service actually has a record for that name, which I'm trying to reach, and that service is set up to return the correct IP address of the service which is working right now. And how does it understand which server is actually accessible? There is an additional entity, that one, and there are two additional entities actually, the monitors. And the monitors, it's like a procedure that is being executed by the NS1 service, and that procedure should return a correct answer. So if the web server is accessible, it's supposed to be returning the like HTTP 200, and based on that status code, NS1, like the monitor within NS1, can understand if the server is accessible or not. If the server is accessible, it returns the correct IP address of that server. So for now, NS1 understands that the server, my server number 1 is not accessible, but the server number 2 is definitely accessible. It's visible because it's green, and like that means it's down, and green color means that it's up. So it's returning this very IP address if somebody asks for like Rocky Cool US. Let me check it. I don't know if that's another. So that would be the correct. So let me do it. And yes, this is the correct IP address. 6 at the end. Yeah, that's it. So that means if anyone here is going to access this DNS name, yeah, it should return the IP, like since you're going to resolve the name into IP address, and the IP address will be the correct IP address, and you will be connecting to the correct web application. So remember, there are two web applications, and now we're working with the application number 2, and it's not visible because they're definitely the same. They use the same code, the same everything, except the fact that they use different databases to fill the page. So let me add some data using server 2, right? 2. So for now we have two strings of code, 2 lines of code. Both of them are located in the database, in like one table of database. Again, it's like definitely not something useful at all, but it shows the concept. So for now we're working with the server number, like the chain of servers, like number 2. And what I'm going to do is I'm going to 6 minutes. I'm going to switch back. I'm going to make the back failover to server number 1. So let me do it. So again, this is the easy procedure. It usually takes, I don't know, 3 or 5 seconds. So what's happening right now? For now we have server number 1 was like made primary, and for now I believe we will see significant difference in our web application. So that application number 1, it should start working. Yes, it works. And the application number 2 should probably start showing us, yes, it's like it's pretty visible that something is happening, but we don't see any updates. So it basically waits for the server to have any answer at all, and that, yeah, and we see that ugly error message. So let me refresh the interface of NS1, and we see that we are now back to server 1. I mean, while I was talking about what was happening and what I was going to do, the NS1 already, NS1 service already understood that I have only one server available, and that server has been changed. And for now, I'm going to, let me check it. I'm going to check which IP address will be returned, and you see there is a definitely difference. So it looks like NS1 understood it already, and let me do that. This is I didn't press the refresh button yet, because I wanted to show that this information was received, was linked to the server number 2. And if I press refresh, it's already started working with the server number 1. And what is interesting here, and that it's quite important, that you see that there is the same set of data available, since both of the SQL servers are like handling the same data. And here I used a synchronous how it's called correctly. Let me just check it. Yeah, synchronous commit. And that means that when you try to commit your transaction on one server, it will not be committed until the transaction was transferred to the other server, and then there should be like commit approval from the the second server, something like this. I don't think that this is exact and correct picture what is happening, because there should be some kind of log related transactions. I mean, I believe on the second server the transaction should be put in log, maybe not in the database yet, but still the commit of the transaction is confirmed. Like the commit of transaction on the first server is confirmed, then the second server like put the transaction into the log. That is probably what is happening when the that asynchronous commit is being executed. So yeah, what the primary source of data was transferred from server 1 to server 2, and then from server 2 to server 1, like back. And while the data was located on the server 2, the web server 2 was connected and returned the correct data. And since the data was correct, the server NS1 started returning the address of that server number 2, like to any client who wants to connect to that that DNS record, or that DNS, I don't know, server, anything. And then we switched back, everything was back, and it actually took several minutes. For now it's 12 minutes already, but it usually takes something about like 3 minutes or 5 minutes, something like this. And I spent more time trying to explain. I don't know, I hope I really helped to understand how it works. basically, I wanted to say that that scheme works automatically, so you don't have to do anything. It just takes time to refresh your DNS cache and to NS1 for NS1 to understand that one of your servers is not available, but the other is, and that's kind of the idea of the whole scheme, and it is possible to implement it since that scheme is already implemented within Microsoft Azure, so without any real physical devices or like any data center, like I don't know, on-prem data center involved. So it is possible to implement that scheme like in your hybrid infrastructure, so you can use Microsoft Azure as a disaster recovery site for your data center, running all of your applications on this very technology. So this is how it works. This is how it looks, and I'll be glad to answer your questions if there are questions in the comments under this very video. Thank you for your time, and hope it helps.